Good morning, students. Dear students, as in the previous video, we had discussed about static friction, and while discussing this static friction, we had learned that when a block of mass m is placed over a rough surface, then as the force F is applied on that block, then a opposing force parallel to the surface is generated due to the applied force, which restricts the motion of the block on the rough surface. And that opposing force, which is applied parallel to the rough surface to oppose the motion of the block, is the reason for the generation of static friction. Now, today we will discuss another type of external friction, that is limiting friction. So, today we are going to discuss about the second part of the external friction, that is limiting friction. Now, dear students, what is the meaning of limiting friction? First of all, I want to explain you about the limiting friction. Suppose this is the rough surface. And a block of mass m is placed over this rough surface, and a force is applied. As we have applied the force F on this block for the moment of mass m, then as per the previous discussion, a force of friction is automatically going to be generated, that is called as static friction. Now we are going to increase this applied force, and as we are going to increase the applied force for the movement of block of mass m on this rough surface, then obviously this value of limiting friction, this value of static friction going to be increased. And as this applied force goes on increasing, a condition is approached that the limiting, because it will increase up to a certain value. And after that, the applied force counterparts the static friction, it counterparts the static friction, and the block starts moving. That value of static friction over which, that maximum value of static friction over which the block starts moving is called the maximum value of static friction. It is called as the maximum value of static friction, and this maximum value of static friction is called as the limiting friction. So, dear students, we can say that limiting friction is the maximum value of the static friction over which at applied force F goes on increasing, the block starts moving over the surface. So limiting friction is the maximum value of static friction. It is maximum force of static friction which comes into play when the body just starts moving over the surface of the another body is called as limiting friction, or you can say that static friction must be less than or equal to Fs max. And this Fs max, maximum value of static friction, this is called as the limiting friction, limiting value of friction. This is called as limiting value of friction. So dear students, I want to explain you by drawing a graph. Look at here. Suppose this is x-axis and y-axis, and here we have given the applied force. We have given the applied force, that is F, and this is the static friction. This is the static friction. Then, as the applied force is being increased, the Fx is also going to be increased, and at a certain value it is the maximum value, and after that it becomes constant. So this value is called as, this is called as Fs max. This condition is called as Fx max, or limiting value of friction. This is the limiting value of friction. As you are going to increase the applied force on the block, then the static friction also goes on increasing, and up to a certain value, up to which the block does not have started moving. This is the maximum value of the static friction, and as the applied force is going to counterbalance this static friction, then it decreases and acquires the constant value. The frictional force acquires the constant value throughout the motion of the block over this surface. So this value is called as the limiting friction, Fs max. Now there are certain laws. Now we will discuss about the laws of limiting friction. Yes, dear students, now we will discuss about certain laws which is related to limiting friction. So there are 4 laws related to limiting friction. The first law is limiting friction depends upon the surfaces which are in contact. It means to say that, students, what is the roughness and the smoothness of the surface? Based on this, the limiting friction depends. If the surface is more rough, the value of limiting friction is more, and if the surface is smooth, then the value of limiting friction is less. Second point is limiting friction always acts parallel, oblique, tangential to the surfaces in contact. The third point is limiting friction does not depend on the areas in contact. Until the normal reaction does not change. It means to say that this statement is that suppose we had kept a block over the rough surface, then the value of limiting friction always acts, Fs max always acts tangential to the surface or parallel or tangential to the surface. And second thing is that the limiting friction does not depend on the areas in contact. Means to say that if there is a block kept over this surface, then this is the area of the contact. This is the area of the contact, and this is the normal reaction, and this is the weight mg. Now, if we does what? Suppose this is the rough surface, and on this rough surface we had kept a block of this area. Now here, look at here. The area of contact in this case is more as compared to area of contact in this case. So, but if I am saying that okay, R dash and this is mg and R dash. So if I am saying that okay, this is case first and this is case second. So if I am saying that okay, if R is equal to R dash, if R is equal to R dash means both the blocks are of same weight, then the value of limiting friction F max is same in both cases. The value of F max is same in both the cases until this normal reaction not going to change. But if R dash is greater than R, then if R dash is greater than R, then F max is not same in both the cases. Means if the normal reaction is going to be changed, then the limiting friction Fs max also changes. But if the normal reaction is same but area of contact is different, then the value of limiting friction, that is Fs max, always remains same in both the cases. Now, dear students, we are going to discuss about the fourth point. Now students, the fourth point is that suppose we have kept a block over a rough surface, and as we have kept a block over the rough surface, then its weight is mg, which is acting downward, and due to Newton's third law, a normal reaction is applied here, and this is the value of Fs max. This is the value of Fs max. So here, as we had discussed in the case 3 or third law of the limiting friction, that is Fs max is directly proportional to normal reaction, because as normal reaction changes, the value of Fs max also changes, or you can see that Fs is equal to mu s max into R, or you can say that mu s max is equal to Fs max upon R, and this mu s max is called as coefficient of limiting this Fs max is called as the mu s max. This is the, since to replace the constant of proportionality, we had placed a constant that is called as the coefficient of limiting friction, and it is denoted by mu s max. So the value of mu s max is equal to Fs max upon R, and mu s max is called as the coefficient of mu s max is called as the coefficient of static friction or coefficient of limiting friction. So you can write it as limiting friction upon normal reaction. Limiting friction upon normal reaction, and this is called as the coefficient of limiting friction. Clear, students? This is weight mg and this is normal reaction R. This is Fs max, that is the limiting value of the friction. So as we had studied that the limiting friction is directly proportional to the normal reaction. So from here Fs max can be written as mu s max upon R, or mu s max, the coefficient of limiting friction, is equal to Fx max upon R, that is limiting friction upon normal reaction. So this is called as coefficient of limiting friction, and it depends upon the surfaces in contact. It depends upon the coefficient of limiting friction depends upon the surfaces. It depends upon the surfaces, whatever the surface, these two surfaces in contact, it depends upon the surfaces in contact. Now dear students, we will discuss some numericals based on the basic numericals. We will discuss the basic numericals based on the coefficient of limiting friction. Then we will discuss about angle of friction and angle of repose. So now dear students, look at the numerical. Here a horizontal force of 950 Newton is required to slide a sledge weighing 1200 kg kilogram force over a flat surface. Calculate the coefficient of friction. So very simple numerical based on the formula. Look at here. Suppose this is a sledge, and here there is certain mass. Slide is sledge weighing. This is sledge, and its weight is kgf. Its weight is given and 918 Newton. 980 Newton is force is required. So we have to calculate the coefficient. We have to calculate the value of mu s max. We have to calculate the mu x max. We have to find out the value of mu s max. So we know that Fs max is equal to mu s max into R, and from here a force of 980 Newton is required. So 0. mu s max, value of mu s max is given. Mu s max is equal to 0.4. It is also given in the question. So we have to find out calculate the frictional force. We have to find the value of limiting friction. We have to find the value of coefficient of friction. So mu s is equal to Fx max upon R. Mu s is equal to Fs max upon normal reaction. So normal reaction is equal to what? This is normal reaction, and normal reaction is equal to V, that is equal to mg, and it is equal to into 9.8 Newton. That R is equal to mg is equal to 9.8 Newton. So we have to find out the value of horizontal force upon R. Horizontal force 980 Newton. So we have to find it, putting the value, that is equal to 980 upon into 9.8, and from here we will get the value. It is equal to 100 upon 1200. It will cancel out and it becomes 1 upon 12, and its value is 1 upon 12, and its value is 0.83. 0.8. So we have to calculate the value of Fs max, and mu s is equal to mu s max coefficient of friction. We have to calculate mu s is equal to Fx max in R. So look at here, the Fs max, value of Fs max, Fs max. So the value of Fs max for the limiting value of friction, the Fs max must be equal to 980 Newton. So we had replaced Fx max with 980 Newton, and normal reaction R is equal to mg. From normal reaction we had kept the value 1209.8, and its value will be, so mu s max is equal to, so mu s max is equal to 0.8, mu s max is equal to 0.8. Now look at the another question. Now dear students, look at another question. A block of mass 2 kg, this is of mass 2 kg, is placed on the floor of the coefficient of static friction 0.4. The coefficient of static friction mu s is given, given mass m बराबर m is equal to 2 kg, mu s, coefficient of friction, static friction, mu s is given 0.4 and a force of 2.5 Newton. F force, that is applied force for the movement of the block, is 2.5 Newton applied in the block is shown in figure. Calculate the friction. Now look at here, the normal reaction. This is m into z and it is equal to the normal reaction. So R is equal to m into z and it is equal to 2 into 9.8. This is the normal reaction 2 into 9.8. Now based on the formula Fs, we have to calculate the force of friction. So Fs is equal to us into R. So from here us is given and normal reaction is given. So we can find out 0.4 into 2 into 9.8 and its value will be 0.4, its value will be 7.84 Newton. Its value will be 7.84. Its value will be 7.484 Newton. So here, look here students, the force of friction Fs here, Fs is greater than the force applied. F applied, the force applied, Fs is greater than the force applied. It means to say that the frictional force here, the frictional force is great. Frictional force is the 7.84 Newton and the applied force is 2.5 Newton. So frictional force is greater than the applied force. So do you think the block will move? No. The block will not move due to applied force. Means due to this applied force, the block will not move because the frictional force is greater than. So for the movement of the block, applied force must be greater than the frictional force. Applied force must be greater than the frictional force for the movement of the block over this surface. So dear students, this is all about the static friction and limiting value of friction, and we had solved the numericals based on this also. So in the next video we will discuss about the angle of friction and angle of repose and numerical based on this. So that's all for today students. Thank you. Have a nice day.